number is denoted by a plus bi, where the a is real and this is the imaginary. We had already talked about the real numbers, but let's consider the imaginary numbers. The imaginary numbers are numbers like the square root of -4, which cannot be computed by most of the calculators. So to do this, we can write this as the square root of -1 times 4, which equals to the square root of -1 times the square root of 4. So this can give us this square root of -1. We use I to denote it, times the square root of 4 is 2. So this will give us 2i. So this type of number is called imaginary number. So if we now combine this with the real number that we have already discussed in our last video, then we get what we call complex number. But this type of number, like I said, we can denote it with a plus bi. The one with I is the imaginary, while the one without I is the real number. All the number that we have already talked about, they can be written like this. Like 2 can be written like 2 plus 0i, which means the imaginary number in this case is 0. So if you come across something like maybe 2.3, which is still under a real number, this 2.3 can be 2.3 plus 0i. So every number that we had already talked about, they are still under the complex number. So we can say that real is a subset of complex number. Okay, now the addition and subtraction of complex number. Now I want to see how to add and probably how to subtract a complex number from another complex number. If I given z1 to be equal to 3 plus 4i, z2 to be equal to 5 plus 7i, and z3 to be equals to maybe 2 plus 6i, we can compute z1 plus z2 plus z3. We can do it like algebra if you like, but to make life easier, I'm going to use the very easy method. So like to do this, we can just write z1, which is 3 plus 4i plus 5 plus 7i plus 2 plus 6i. So this, we can add all the real numbers, then all the imaginary numbers. Like you can say 3 plus 5 is 8. 8 plus 2 is 10, we have 10, plus 4 plus 7 is 11. 11 plus 6 is 17i. So that will give me the sum of the three. Just add the real together, then we add all the imaginary together, then we obtain the sum for the complex number. So if you have to find z1 minus z3, so this will be equals to z1 is 3 plus 4i, z3 is 2 plus 6i. So we can subtract. What we need to do here is subtract this minus this will give me 1 plus this minus this will give me minus 2i. So and plus minus is minus. So this gives us 1 minus 2i. The answer. Good. Now we want to add, if given z1 to be equal to this and z2 to be this, we want to add and we also want to subtract. Now let's start with addition. So z1 plus z2. Using our same method, z1 is 2 minus 7i, while z2 is minus 2 plus 4i. We are adding in this case, this is plus. So we are using this plus here. Say 2 plus minus 2. And we say 2 plus minus 2. When you have the same sign, the two of them become plus. When you have different signs, the two of them become minus. Because this one, they are not the same, so it's minus. So you have 2 minus 2. And 2 minus 2 is what? 0. Which means the answer to this is 0. Then for the second one, we're having plus here. That is minus 7 plus 4. Minus 7 plus 4. And see, the two of them are the same. The two of them is plus. So we have minus 7 plus 4. And minus 7 plus 4 will give us minus 3. So this is what? Minus 3i. And since we're having 0 here, we can ignore it. So we have what? Minus 3i for this. Now let's consider the one with minus. That is z1 minus z2. Now I want to subtract. z1 is 2 minus 7i. z2 is minus 2 plus 4i. Now we want to subtract. The first one we have 2 minus 2. As we're having 2, we are taking away minus 2. Since we're having the same sign in between them, the two of them become plus. So it's now 2 plus 2. So the answer is 4. Second one, we have minus 7 minus plus 4. So see, the two signs are not the same. The two of them become minus. So we have minus 7, the two of them become minus 4. That is minus 7 minus 4. And minus 7 minus 4, that should give us what? Minus 11. So we have minus 11i. That will be the answer. Now multiplication. Now we want to learn how to multiply complex number by another complex number. Before we do that, let's recall that square root of minus 1 is equals to I. And if that be the case, if a given I squared is equals to I times another I, and that will give us square root of minus 1 times another square root of minus 1. Or we can call it square root of minus 1 or what? Square. Then this we cancel this. So we have minus 1. So anywhere we see I squared, so I squared is equals to minus 1. So we call that. And if that be the case, then I cube equals to I squared times another I equals to minus 1 times I equals to minus I. And I to power of 4 is equals to I squared times another I squared equals to minus 1 times minus 1 equals to 1. Z1 is equal to 2 plus 3i, and Z2 is equal to 4 minus 5i. Now we want to find Z1 times Z2. We want to multiply this by this. So this will be equals to, what is Z1? Z1 is 2 plus 3i. Z2 is 4 minus 5i. Here, only what we need to do here is to expand. I'll use this 2 to multiply everything in the second bracket. I'll use this plus 3i to multiply everything in the second bracket. So here we have 2 times 4 is 8. 2 times minus 5i is minus 10i. 3i times 4 is plus 12i. And 3i times minus 5i will give me minus 15i squared. And recall that I squared equals to minus 1. So anyway you see I squared, you change the sign you have here. So that will be equals to 8 minus 10i plus 12i plus 15. I change this sign because of this I squared, because I squared means minus 1. So here now we can now collect the like terms. We have 8 plus 15 minus 10i plus 12i equals to 8 plus 15 is 23. Then minus 10 plus 12 should give me plus 2 will be i. Now division of complex number. Now if you're given z1 to be equals to 2 plus 5i and z2 to be equals to maybe 3 plus I. Now we want to divide z1 by z2. To do this, you need to what? To know how to find the conjugate of a complex number. And to do that is very easy. Like the conjugate of z1 can be denoted by this. Just put the bar on top to show the conjugate. And the conjugate of this equals to 2 minus 5i. The conjugate means just change the middle sign. If it's plus, change to minus. If it's minus, you change to plus. That's conjugate. Like the conjugate of this one, z2, the conjugate of this, just the bar on top here. So the conjugate of this should be equal to 3 minus i. The conjugate means just change the middle sign to this. But in this case, I don't need the conjugate of the numerator. I only need the conjugate of the denominator, which means this one is not needed in this case. I only need the conjugate of the 100, which is the denominator. So in this case now, I'll write this to be equals to z1, z2, the conjugate, over z2, z2, the conjugate. I'll use the conjugate of this to multiply both the numerator and the denominator. So now this now will be equals to z1 is 2 plus 5i. The conjugate of this is 3 minus i over z2 is 3 plus i. The conjugate of this is also 3 minus i. I repeat again. I'm still having my z1 and z2 respectively as they have. As in z1 is still on top, z2 is still under. Then and now use the conjugate of this. The conjugate of this is 3 minus i. I use for the two of them. So now I will now expand. Just the same way we did multiplication, I will use this for the two of them, use this for the two of them. So we have 2 times 3 is 6. 2 times minus I is minus 2i. 5i times 3 is plus 15i plus 5i times minus I was minus 5i squared. When we do the same thing with the denominator, we have 3 times 3 is 9. 3 times minus 1 is minus 3i. I times 3 is plus 3i. Then I times minus I gives us minus I we squared. So that will be equals to 6. This and this can give us plus 13i. Then since I'm having square here, it will change this sign to plus 5 over, this is 9, minus 3i plus 3i, this will cancel out. I only have plus 1 here because of this. This will go minus 1. So this will be equals to, this is 6 plus 5 plus 13i over 10, because 9 plus 1 is 10 and 6 plus 5 is 11. So we have 11 plus 13i over 10. That's the answer, although the answer can be written as 1 over 10, 11 plus 13i. You can also write like this. Thank you.